Hello, I'm Anna Mackay and this video is on expected value and it's part 3 of this series. So fair games. When playing a game that involves money to play, the expected gain for the player is the expected payout from that game, less the amount it costs to play. This will make sense when we put it into practice. We usually let capital letter X represent the gain from each game, how much we're getting, earning. And bearing in mind that a fair game will have that expected value equaling 0. So the steps for solving, I would advise you to write these down and follow these steps for every question. Now, sometimes you won't need them because it'll be fairly obvious to you, but it's good to put it into practice for the easier questions so that when we get to the harder ones, you've already got this process in place for what to do. So 2 examples. We have a spinner here. And when the spinner is spun, players are awarded the corresponding amounts, and it costs $1 to play. We have to work out the expected return on one spin and then the expected gain. And is it fair? So you might ask yourself, okay, well, it costs $1 to play. Should I play it or not? Well, half of that spinner, I'm going to earn no money, so I'm going to lose my $1. But on the other hand, the other half of the time, I'm going to earn some money. So let's work out mathematically if that's fair or not. So we always start by saying what capital letter X is, and most of the time in these situations it's going to be the gain. Now, so these are our steps for solving what is X. Step 2 and 3 are similar. What are the possible values of X? So how much could we gain each time? 2, 1, 10 or 0. And then what outcomes are required to get those X values? So what do we need to get the $2? Well, we need to land on blue. So from here on in, I'm going to suggest you set up a table with 3 rows every time, not 2 that you've been doing in some questions. So we're going to write, I didn't do that very well, outcomes. We're going to have X, and here is the probability of each of those X happening. So this little X is the gain as a refresher. So we've got 1, 2, 3, 4 outcomes there. So we'll have 4 columns. And so the outcomes are, in this case, the colours that it could land on. So we've got red is the biggest, blue, and then green and yellow. So in some ways that's step 3, what outcomes are required to achieve the X values, and the X values are the different types of gain. So for red, we would gain $0, blue is 2, green is 1, and yellow is 10. Looking back at our steps, what are the probabilities of these outcomes? So now we'll have to work that out. The probability of red, $0, is a half. Now you can use fractions or decimals, that's fine. Blue, chance of that is easy to see as a quarter, and green and yellow are an 1/8 each. Something else worth pointing out is that these must add up to 1. The probabilities of every scenario happening must add up to 1. So if your table doesn't have that, you need to go back and refill something in. Now, our expected return on one spin. So it's the chances of each of these happening. So we multiply these together and then add them up. So I'll show the setting out. So we're multiplying and then adding. Whoops. Feel free to pause and fast forward if you like while I write this out. And then 10 times by an 1/8. And that gives us 1.875. So that's our expected gain per spin. Now you can never earn $1.875 on any one spin, but that's sort of an average over time if you like. So our expected gain is that number there minus how much it costs to play. And we get 0.875. Sort of what does that mean? I'll just write a little note here that if you played 100 times, that you would earn approximately $87.50. So that although you can't earn that on any one spin, that over time you'd have lots of different combinations of how much you'd earn, that if you did 100 spins and you spent $100, you would earn on top of that $87.50. So that's what that number means. So is the game fair? Yes, in this case. I've run out of room to write that though. And one more example. A player selects a marble from a bag containing 20 marbles. If the marble is blue, they win $4. If it's green, they win $6, and it costs $3 to play. So first of all, let's work out the expected gain, but let's follow our steps. Name what X is each time. So X is the gain, how much we gain each time. So let's draw up our table. 3 rows, and we label outcomes. We label little x, and then here is the probability of choosing any one of those x's. So think about the question here. If it's blue, let me reinforce these steps though. What are the possible values and the outcomes? So an outcome is blue, so we'll put blue here. And what are the possible values? So if we get that blue, what are we going to get? We're going to get $4. If we get green, we've got $6. Now I'm going to pretend I can't see this bag of marbles over here at the moment and show you what you might do if you didn't notice that either. So you go, okay, what are the chances of getting each of those? What's the probability of getting blue? All right, well, now we'll need to count up how many blue in total. All right, 1, 2, 3, 4, 5, 6. 6 blue out of how many marbles in total? 20. What about the green? What's the chance of getting a green marble? 1, 2, 3, 4, 5 out of how many? 5 out of 20. And part of you might go, okay, that's the only thing the question's mentioned, I'll move on. But this is where you have to remember that this row here must add up to 1, all the probabilities. So what's left over? We've got the red marbles. And how many of them? There are 9 out of 20. And so you could call them red, or you might just say other, because you might have a scenario where it's any other colour. And how much do you get if you select one of those marbles? Well, it doesn't say, which means you're going to get nothing. So make sure you put in that outcome, that expected value for X. And now, for that X, and now let's work out the true expected value for choosing any one marble. I'll show the setting out. Feel free to fast forward. Where you multiply, that's not quite right, the X values with the probability of each of them happening, add them all up, and work out our value is $2.70. But what's the expected gain? That is how much we expect to get per spin. It's a bit tricky to write my iPad when it's down the bottom here. I'll just draw an arrow. We've got $2.70 minus how much it costs to play, which is $3. So that means we are losing 30 cents on average each play. So it's not a fair game. But how much, when would it be a fair game? So if we're expected $2.70 per selection, if the game cost $2, then we would make 70 cents on average each time. Okay, so that's the end of this video. If you liked it, give it a thumbs up and subscribe to the channel, and the next video in this series will be variance and standard deviation. Thank you.